Hello, in this session we are going to describe the extraction of copper from copper pyrite. Welcome. As you can see on the board, copper pyrite is ferrous copper 2 sulfide. Now, to be able to extract copper from copper pyrite, the first step is that of roasting. And roasting is a procedure which involves burning in excess air at high temperatures, approximately 1600 degrees Celsius. As you burn the copper pyrite in excess air, oxidation occurs readily, reducing the copper 1 sulfide ferrous into copper 1 sulfide without the ion. And then the impurities, namely iron and sulfur, are also oxidized into their respective oxides. So we have iron 2 oxide and sulfur dioxide. Now, as you balance the equation, you find that the procedure is okay. You get 3 there and 2 there, and that is a balanced chemical equation for the reaction process. So the required agent, which is carried to the next step, is copper 1 sulfide. The copper 1 sulfide is carried to the next step, and then it is oxidized with excess air at roughly 1000 degrees Celsius. And when that reaction occurs, the copper 1 sulfide is reduced to copper 1 oxide with sulfur dioxide as the waste byproduct. Now, once copper 1 sulfide is formed, it is proceeded to the next level where it's reduced readily by either solid carbon or by gaseous carbon monoxide. Both are reducing agents. The only difference is the temperature at which they occur. When the reduction happens with carbon, it has to be at high temperatures in order to be able to break down the strong bonds of the solid carbon. However, when the reduction is with the carbon monoxide, the temperatures are relatively lower, between 700 degrees Celsius to less than 1000 degrees Celsius. What happens? When you reduce the copper 1 oxide with carbon, the net result is that what is formed is temperatures above 1000 degrees Celsius. And when the reaction occurs, we get copper and sulfur dioxide as a main product waste. And then the molecules will increase in that respect. We will have 6 molecules of copper, which is forming and is in molten state. So the advantage of using copper 1 sulfide as a reducing agent over the use of carbon 2 oxide and carbon is that, 1, there is an increased yield. 2, it is of low cost, obtained readily from the raw material, and 3, reduces the chance of poisoning. The chance of poisoning the extract. Good. So that is the procedure for extracting copper from copper pyrite. What then are the physical and chemical properties of copper, and how are these used in determining its applications? Remember, the physical and chemical properties control the use of each substance. So we're going to look at this briefly. Copper 1, in terms of the property, let me look at properties. And then on the right hand side, I look at the applications. So copper is a red metal, so it's actually reddish brown. It has a low melting point and boiling point. It's a good conductor of both heat and electricity. And it is malleable, which means it can spread into sheet, and it is ductile. It can be drawn into wires. Now, the fact of it being malleable makes it suitable for use in manufacture of electrical plates. Let me talk of heat plates, and electrical cables. Now, because it is ductile, it can be drawn to a wire. We use it to manufacture electrical cables, and it is a good conductor of electricity. Because it's a good conductor of heat, we can use it to manufacture heat plates like those of the iron box. Good. It can also be used to manufacture the interior part of an electric kettle. And number 3, copper, when combined with zinc, forms what is known as brass, used for making cooking utensils. When copper combines with tin, then it forms bronze, which can be used to manufacture medals or coins. When copper combines with zinc and tin, it forms German silver. The German silver can be used to manufacture coins or medals. So copper is an important metal, and as we have seen, the main ore for extracting copper is copper pyrite. There may be other ores in form of cuprite, which is dicopper dioxide, and many other varieties. So long as the percentage of the metal is higher than 50% in the ore, then it is referred to as an ore of that particular substance. Thank you.